The topologies that we have discussed, we have different topologies. That means depending on our requirement, we can connect computers together in different way, physical connections. So bus topology, star topology, ring topology, and mesh topology. So these are the ones we have discussed. But when you look at how to connect them, you need some network devices. So usually these hubs and switches are, common network devices, and it will be part of the network, right? So we can start with that. So hubs and switches are common devices that could be found on networks. So that's the first thing we need to know. So these are common ones. Right? So when you talk about the hubs, for example, and if you want to look at what is the difference between hubs and switches, right? So we know that in a hub, right, we will have similarly with the switch. That means from one point, it will distribute data to the other point. The difference is um, now when you get the data for a hub, it will distribute to all the outgoing connections, which means it will distribute or broadcast, we sometimes say, the message, incoming message to all outgoing lines. So that's for hubs. But if you take switches, switches are more intelligent. Switches are more intelligent, and switch will, forward the incoming into the exact place, right? So that is one of the differences, right? So let's start with the hub. Let's take down hub. Hub so usually looks like this. I hope you have already seen. Let me just uh, show you a picture of this, right? Then let me paste it. Yes. So something like this. So this is hub, right? Look, the look and feel will be the same, right? So the hub is, I told you, it's one of the devices you could found in a network, right? Uh, Hub forwards incoming data to all outgoing connections. So you can say that this is a hardware device, right? And then it'll, distribute this. from one point to other. Right. When you take a switch, on the other hand, right, let me show you similar to, now it looks similar. Right? More or less the similar if you look at, but usually you have more ports than the hubs, right? So let me show you a one more. So simply something like this. Let's say here we have 8 port hub, you can have 16 and so on. But usually when it comes to switches, you have more ports, more connections compared to uh, hub. So switch has more connection compared to hub. And I told you like switch is more intelligent. It is more intelligent, right? It is more intelligent, right? For example, switch, we can say, for example, like this, right? So one of the examples. So when you get the incoming connection from this case computer A, it will send it to computer C. It won't go in the other directions. But in hub, for example, if this was a hub, then it'll, when you get it, so it might forward it to all the computers. So switches are more important. Switch receives data in one connection and then sent or forwarded into to the destination. Switch direct. Therefore, we can say the switch is more intelligent than the hub. So remember this. This is very, very important. It's actually slightly off topic that we were discussing from this section. Right, okay. Now we'll look like to go for the other section. With that one, we finish the previous section, unit 6.5. And what we were discussing is telephone network modularization. And then also we discuss different topologies. So that was the main content that we want to discuss. Now here we are going to talk about the next one. It's 6.6, right? We are going to look at what we call media access control protocol. I will explain what those are, right? Now, in the if you take a network, we need to uniquely identify each of the devices. I hope you remember, especially in internet, we could use internet protocol, IP address for that. Likewise, we can also use devices individually. Now, what do you mean by that? Now, to identify these devices individually, we can make use of what we call MAC protocol or media access control protocol, right? So let's say our main topic here, 6.6, we are going to look at media access control, or in short, we will say MAC protocol. Right. Now, before we talk about this media access control protocol, we would like to discuss the local area network, right? Now, let's start looking at a subtopic. Let's look at what is local area network. Okay, Nimesha, I hope you can help me out. So in this part, we are going to discuss media access control or MAC protocol. But before that, let's start with looking at what a local area network is. So we already know now networking is connecting computers together. And when you connect, devices together in a small area, like a building, we call it a local area network. So if you take a computer network in a school or a university, you can consider it as a local area network. And there are various advantages, but if we summarize some of them, you can share resources. So here, when you say resources, it could be both hardware and software. So you can share a printer among multiple computers. You can share a software you can install in one machine, and the machines in the network can make use of that software. So you can reduce the cost. And then high security, right? Especially in a network computer environment. So you have to have username and password. Without username password, you cannot log into the system. So that which means only authorized users are allowed. Then communication is easy, right? Most of the time, now the users of the network can communicate each other with these digital communication techniques like email and use of messengers. Right. The second one is we would like to discuss about identifying the devices. And there are two ways of identifying the devices, right? The first one we call IP address, which we have already, discussed earlier. So what is IP address, right? So in IP address, there'll be, four numbers where these numbers could be used to individually or uniquely identify each of the the machines in a network, right? Especially in wide area network, when you're connecting to the internet, the IP addresses are used, and this is called logical address, right? So we call this is the logical address, IP address, right? So logical means it's not a permanent one, right? It's a temporary address. So we can say a temporary address given to the devices in a network, right? So you can say that there are like, right? If you remember what we have discussed earlier, right? In the internet, we discussed these ideas earlier, that when you say IP address, you have four numbers, and then how many bits we were using? We were using 8 bits number, right? Which means the numbers can go from 0 to 255. That means 256. Right? 256. Okay. Right. So 8 bits means, so for using 8 bits, you can represent 256 numbers, 256 total numbers, and that means the size of the IP address is 18 to 30, sorry, 18 to 4, that is 32 bits, or you can say 4 bytes. So remember, that is very, very important. Right. So let's take down the temporary address given to the devices in a network, right? And we can say IP address is 32 number users computers communicate each other in a network environment, and there are 8 bits numbers and with a separate of, right? So let me write down that. Okay. Temporary address given to the device and network. IP address is 32-bit because one number is 8 bits. So 4 8-bit numbers. That means the value goes from, right? The valid range should be 0 to 255. Right. Let's take down this. MAC address we known as a physical address, and it's a unique address, right? And permanent address. So this is basically given by the manufacturer. Like in earlier, the size of the address is 48 bits. In previous one, it was, right, 32 bits. So in this case, we have 48 bits, and there are 6 8-bit blocks. And then when you take first 3 blocks, right, is used to identify the manufacturer. By the first 3, we are going to identify the manufacturer. The last 3 used to identify the device. Last 3 blocks are used to identify the device. Okay, let's take down. So what you need to remember is it's a unique one, it's a permanent one, and the size is 48 bits, means we have 6 into 8-bit blocks, and the first 3 blocks to use for manufacturer, last 3 blocks to identify the device. Okay. Okay. Now we can give an example, right? Now, for example, in my machine, if I take my machine, if I take you can type ipconfig all. If you just type ipconfig/all, so you will get this, right? So in my case, let me share my screen. Okay, so this is my screen. Now I'm going to see my MAC address. I'm going to say ipconfig/all. Now, if I do that, then if you go through the details given, right, IP configuration, it says, right, and then it says physical address. Okay, so this is my address, physical address, right? So this will give you an idea of what exactly we will have. And then there are another set, local area network, Ethernet adapter, physical address, LAN adapter. So all these details are given here, right? So the MAC address, Ethernet adapter, Ethernet, right? We have given here LAN adapter, local area network. So these are like, when you're getting this, it's called MAC address. You can get these numbers. So let's write down an example. If you look at local area network, and then this is, you can look at the details. Okay. So any machine, you can find out this. So you have 8 blocks, and I told you, like, the first 3 is for the manufacturer and last 3 is for the device. Okay. So let me take one of my examples. Okay. So let's say Control V. So here is one of the examples. So in my machine, right? So this is example, right? Which means there are 6 blocks, right? We have 8 bits, and the first 3, I told you, first 3 bits, the first 3 blocks, this is from the manufacturer, and this is to identify the device. Right? This is an example. So it's given in hexadecimal, right? Each one is 8 bits, right? Go from 00 to FF, right? You remember, this is given in hexadecimal. Right. Now, before we move on to the next part, we also would like to discuss a couple of things. One thing we would like to discuss is what are frames. Now, what we will explain what frames are. Now, this is for sending data from one point to another point, right? So now we actually completed the discussion of MAC addresses. So let's move on to the next subtopic, that is frames. Frames. Right. Later on, we will actually discuss in detail. Now, when you're sending data, there are different layers. What do you mean by layers? When you're transmitting data, you can transmit in multiple levels, right? So in this particular case, we are going to use data link layer, right? Meaning we are going to use data packets. Now, packet of data means you have a set of bits, and then you are going to put as the packet is there, right? So when it comes to data link layer, what we are trying to transform, or we are trying to transmit, is the frame, right? Okay, right. So we are going to talk about the frames. Frames is uh, when it comes to data link layer, we will send data as frames. What the frame has, you have the data as well as header part and a trail. So in header information, we are going to keep track of sending as well as receiving MAC addresses. That's exactly I want to discuss it here. So we will discuss these layers later on, but for the time being, let's say at the data link layer, data are encapsulated. We put everything together, so that's the meaning. Encapsulated data, encapsulated into the frame. It consists of header, data, and trailer. The header part consists of MAC addresses of sending and receiving. Sending and right. Right. So we will discuss about the data link layer later on, but simply to put, when there are two transmissions among let's say set of computers, it could happen in physical layer. In physical layer, data transmission happen in bits. In data link layer, it will happen in frames, right? So that's only what you need to remember. Right. So that's about the frames. What you need to remember is data transmission happen in different way. At the lowest level, it's bit by bit in physical layer. An upper level, which we call data link layer, is sending and receiving as frames. So in frames, we have three parts. We have head, data, and trailer. And header, the head part consists of MAC addresses of sending and receiving devices. So that's all you need to remember about the frames. More we'll discuss later on. Now, the next thing is to discuss about the protocol. Now, protocol means a set of instructions you will have how to communicate with different devices. So when you say communication network protocol, or the order and the format of data when data is exchanged between two networking devices. So many protocols exist in the networking world, and media access control protocols are enables orderly access to a common shared medium communication. A bus topology, a common medium is shared by many devices, and a medium access control protocol can ensure that medium is accessed in orderly manner before data collisions are avoided, right? So let me explain a bit what this exactly means, right? So basically here we are going to look at how data is transmitted, right? So let's say we have two computers, let's say A and B, right? So A needs to send some data to computer B, right? So what we should do? So whenever you want to send data from A to B, you have to have a way of releasing the data, and then there should be a way to receive the data, right? Now, if you talk about the bus topology, in bus topology, you had single line, right? You have main wire, right? And then you can send send messages in a bus topology. But if you get data in the same time in opposite direction, then data gets destroyed, because then data can collide each other, right? Now, computer A and computer B, these are the places where you can do, but if you send the data in both sides, then there could be collision. Right now, to reduce this problem of collision, we have to use different methodologies. So they are the protocols. That's what we say. It's a protocol. Now, when you talk about the protocols, the very first thing that we want to discuss is called Aloha, right? So the Aloha means you can use carrier signals within the transmit media, and it's free. Right. So let's take down that. So the next thing, as I told you earlier, we are going to discuss so we are going to talk about protocol here, right? So the subtopic that we are going to discuss, a protocol. So it's a protocol. So if you ask me, what is the protocol? It's how exactly you are going to transmit data from one device to another, right? So if you ask me what a protocol is, right? When you say a protocol, the protocol means, right? When you say a protocol is a set of rules, right? Right. Let's write down about the protocol. A protocol is a set of rules used to communicate devices in the network without any collision, right? Collision means, right, without a clashing. Now, for example, let me take the bus topology, right? So if you take bus topology, right, I'm going to copy paste and show you like this. So let's take bus topology. And if there's a data transmission in opposite sides, what do you mean by opposite sides? Now let's say, right, data is coming from here to here, right? Let's say this particular machine wants to send data here, this one, and this data machine wants to send the data to this one. So coming in both direction, right? We have a single line. It's like a road, but in this road you can actually transmit, right, only one data at a time. So when data coming from two different places, when they meet each other, then it will destroy the data, right? It will destroy the data. It will destroy the data. So uh, let's say in a bus topology, right? So you can say in bus topology, what will happen, right? In bus topology, if two devices transmit data in opposite direction, so if you send in both directions, what will happen? It will going to destroy the data, right? In direction, data get destroyed due to collision. Right? They meet each other, they destroy the data. Now for that, what you need? You need a protocol. Protocol means, right, we need some way to communicate the device without any collision, right? Now to avoid this situation, right, a protocol is needed, right? You need a protocol for that. right? There are many protocols. So let's look at some of the protocols. Right? So there are many others, right? And then we can use, a protocol, right? So one protocol is called pure aloha, right? I will explain what this means. Pure aloha protocol. Now, what is protocol? Again, I'm repeating. Protocol means a set of rules to transmit data without any collision. And I told you, there are many protocols. One is pure aloha. Hmm? Right. In aloha, we are using MAC protocol, right? In a shared network. So using this protocol, we can send data from multiple nodes to transmit multiple points, right? Using this one. So there are two types of protocol. One is called pure aloha. The other one is called slotted aloha. So if you take pure aloha, the time is continuous, right? So whenever you have a frame, then it'll send the frame. And if there's a collision, right, the sender, you wait for some time and then you resend a key. I will explain one more time, right? Now I told you we need a set of rules to avoid any collisions. What do you mean by collision? The data coming from different paths, they collide each other and destroys the data. Now I told you, like in bus topology, if data is to come in, because you have one line, right? One single line. So it will meet, then it will destroy. Now for that, we need a set of rules to avoid this one. And then the first one that we are going to talk about, uh, what you call pure aloha, right? Now in pure aloha, what happens? It will transmit, right? In this particular case, we are using frames. That's why we learned these frames earlier. I told you, like in data link layer, you send data as frames. The difference is, you have a header and tailor. In a header, you have information such as where do you want to go, right? Now in pure aloha, what will happen? It will start from one place, and when you're sending the frame, you wait for some time, right? And if it in reserve, then you resend the key, right? Resend the key. Okay. So there's sometimes collision might occur, and then you resend the details. Okay. Okay. So let me show you one way to do this. So you take the frame and then you are trying to send it, right? Let me show you another image for this one. Right? How data is actually transmit from one place to another, right? Multiple ways. Right? Now, let me explain this with a simple figure. So let's say we have computers. Here we have, it says stations. Sometimes we say sources. And I told you, like, usually you will send as frames. Now, when you send in the data as frames, you see what will happen, right? So you have one line, one channel. When multiple, machines try to send data, the collision happens, right? So for example, here there will be a collision, right? Because multiple frames try to access the unit. And here also there's a collision, right? Collision is there, right? So that's the idea. So collision is there. Now, if you look at how this will work to understand this one, first of all, you have to check before sending Aloha. What they say is, before you send, you check whether there are any other, right? And then you send the data. So for example, if you start from here, let's say station 1 is going to send some data, no other station sends the data, right? Right? So no other data will be collided because there's no other data points. But if you look at this one, when you're trying to send this one, right? Then there are like 3 collisions, right? If you look at station 2 is also, you have a frame, station 3 also sending another frame, right? Station 4 is also trying to send another frame, which means there's a collision. If you look at this second data item, right? So the data will be get destroyed. So here it will not happen because there's no other, station, sensor frames. But in the here also you will see there are collisions, because here also you will see it will collide each other, whereas this one there's no collision. Right. So how we are going to do this? I told you, first of all, you will see whether the frames are free. Right? Then you forward signal if the transmission media is free. So now, for example, if you are trying to send this frame, you look at the other places, there's no other data point, which means you are free, you can send. And then you wait for the acknowledgement, meaning if it is goes to the other side, usually it will say, okay, we have received the data, right? If that is the case, you don't have to resend in the key. So in this particular case, all this data will be destroyed. Maybe you have to send station 2, 3, 4, you have to send these frames again because it may collide. And here also, there are two frames which may collide, meaning you may have to resend the data. So station 2 has to resend all the frames. Station 1 has to resend this frame. Station 3 has to resend this frame. And station 4 has to resend all these two frames. Okay. So remember this. So that's where you have to make sure that, right? So you wait for, whether this channel is free, then only you should forward. Otherwise, this data will get destroyed. And if that is the case, you wait for some time and then you resend again. Right? So this is called pure Aloha. Okay. That's Aloha. The first one, check with the frames are free. Forward frames or signal to the transmission. Wait for the acknowledge. If the acknowledge signal is received in over the next thing. If the acknowledgement signal is not received, then send the file again. That's all we need to do. So that's all. So first of all, it checks whether the frames are free, and if that is the case, you forward and you wait for the acknowledgement. Right? So if there's no collision happens, you get that acknowledgement signal, then you send the second one. Maybe director we will describe the feature. Four devices are connected shown in the above diagram. Suppose four devices transmit data four devices are connected to the network shown in the above diagram. Suppose four devices, let's say this is suppose four devices transmit data to a single transmission. Yeah, because that let's number the, so we can put some numbers. This is one, this is three, this is four, this is five, this is seven, eight. Right. Now let's write down this. See that? Right. The numbers. Right. Like we have numbered earlier, four devices are connected to an internet shown in the above diagram. Suppose four devices transmit data to a single. So we have a single line to transmit data. So what happens according to the diagram we have drawn, right? If you take frame number one, say frame one, you forwarded to the transmission media by the first device is being forwarded transmission media by first device. By first device, there's no other transmission device. Right? Others will have collisions. You see here also collision, but this is again You are right. Okay, පුතේ අපි එහෙනම් අදට මෙතනින් නතර කරමු. බලමු යාළුවා ඉංග්‍රීසි වලින් කියලා අපි try එක ගිය සතියේ කරන්න බැරි වුණා. So let me discuss with the other partner and get back to you.
Okay, sir.